Hi everyone, David Maley here, and today I'm going to show you how to do linear regression. This is a full linear regression tutorial, but it's also an rMarkdown tutorial, so it's two things in one. So I want to show you how to go from the beginning to the end. We're going to go through every step you need to know for linear regression, including appending your scored values in the end, the forecasted values you're going to get. And then we're also going to show you how along the way to create this and document this in rMarkdown. So what you'll end up at the end with is this right here, which is a really cool HTML document made through rMarkdown that shows all of your code, all of your data, or samples of your data. You can't show every row of your data. You could if you want to, but it'd be too long. All of your results, all of your statistical tests, all of your graphs, everything all laid out in a really nice fashion so that it's great documentation, easy for you to pass on to someone else if you're passing on a segment of code to another team or something like that. It's really valuable to know and have. So let's get into it. So first what we're going to do is you create your rMarkdown file. You'd go here and click, file or this and open and say you want to create a rMarkdown file. Now this is in RStudio. If you don't have that yet, you need to install that. Most people that code in R do it through RStudio because it's just so helpful. When you open up, it'll have title, author, date, and output already set up. So you're just going to change these to be linear regression. In this case, it's linear regression rMarkdown tutorial. My name, the date, and how you want your output to be. Do you want a PDF? In this case, I'm doing HTML. Now, next I have videos, links here, and the reason being is I want people to know that you can read this, but you can also go back and watch the videos and go back and forth and try it yourself. And so this way you can quickly get to the videos on this, as I showed in the HTML document. And then I also put the HTML or the web address of the location of where the data comes from. So this data is from the University of California, Irvine's data science department, and it is their auto miles per gallon data set. So it's pretty cool to look at that, and that is a linear regression data set. It's for that, for practicing that. So basically you'll set up a task. So, well, first let me show you this. So when you're doing the links, if you put them in brackets like this before the link, what it'll do, and you have it set like this, what it'll do is it'll have these links or these words hyperlinked to this web address. Okay, and then down below, by putting task with two asterisks before and after it, it bolds that. And then I listed out the steps we're going to take, and then again, same thing to bold something. I have it split up by parts 1, 2, 3, 4, and so on. What you need to do next is when you put your code in, you'll put these three little asterisk marks, and then, or not asterisk, the little hyphen marks on your computer all the way to the left, and then R, and then I want to get rid of warnings and messages. And the reason being is in R you'll get a lot of warnings sometimes that maybe a data type or a format is not necessarily the best or might have some rounding issues. In this case, we're fine with that, but I don't want to see all the warnings for it. I don't want that in my documentation. So by setting these both to false right here, that gets rid of that. Then we, anything you want to comment out, obviously put a number sign in front of it like this, hashtag, and then here's the libraries we're going to use: Zoo, ggplot2, tidyverse, readxl, cable extra. Okay, and I'll show you what they're all going to do down below. Then next we load in the data set. In this case, you just bring it off your local computer, and then we say look at the first 6 rows of data. We do that with the cable extra data set or library right here. So by doing that, we get the top 6 rows or the head of that data, right? You have head or tails, which will give you the top 6 is head, bottom 6 would be tails. I could have done that too, it doesn't matter. And this is the code right here to do that. You can pick the font size you want. Basically what the cable does, it gives us striping with the data so that when you look at it, if I were to clip this to look at it, oh, it doesn't have test data 3, we'd have to reload it in again. So let's do this. What we have to do is this, And let's run this. I'm sorry, I'm used to using RStudio for that without the rMarkdown. Let's put that in there. And then what we have to do is this. Once we've loaded that in, and see how what it does, it makes so that every other line is a different color, so it kind of stands out. It's nice, it's easier to read, easier to look at. And this is what you'll see when you're in your rMarkdown sheet. And so see, I've got the libraries listed here. I've got the code to get the first 6 rows of data, the head right here, and this is what it looks like in the rMarkdown file. That's what we want, because it's very easy to look through it rather than just having a bunch of lines of rows that are not easy to tell apart. So that's where that comes in. And again, this you can see here or in there, same thing. It's just cable of your data frame, which is we put the head of that test our original data into df, and then we do cable of that, and then we put the cable styling is piped into that of striped, font size equals 10, full width equals f. If you don't do this, full width equals f, what'll happen is it'll try and shrink it, and you'll actually have it run over. So it'll actually like cut it somewhere like here, and then it'll have it down below. It looks kind of ugly. So make sure you have full width equals f when you have a larger number of columns like I have here. Just keep that in mind. If you have too many, you might have to split it up. So then after that, we explore the columns. I see how I have it differently here than in here. It's a little bit different. It's just how it shows. When I put those asterisks, it bolds that part, which is nice to help it stand out. And then it shows each of the features or each of the functions. That's why I like to split it out. So I'm showing each piece. I don't have them grouped together, so it's kind of so you won't get lost in reading it. So the str function shows you exactly, here are the columns going down this way, and here is all of the different data. Not necessarily every piece of the data, but samples of the data. So miles per gallon, it could be 1815, 1816, whatever. Manufacturer could be Chevrolet, Buick, Plymouth, AMC, whatever. And then you go through this, and you can remove the NAs from the numeric columns. We have to do that. There are numeric columns. Actually, before that, we have to actually make the columns all numeric. So that's where this little bit is right here. So underneath this, what we're telling you here is we have to use and convert them. So once we've identified there's some that are character like horsepower, we need to change those. So here, right here in this piece here, we're changing them by addressing that one column and then saying as dot numeric parentheses and then that column. So what it's doing is it's just taking that character column and making it numeric, and we're going through each of these that we want to have that way. So miles per gallon, horsepower, and origin are all character in here, so that's what we have to change those over. Now once you're done with that, and you can see it back here or see it there, it doesn't matter, and we can close this off once we've done that. And the same thing here, you can see that. Then after you've removed the NAs from the numeric columns, then what we'll do is go into determining the correlation. So first we want to do a summary to make sure that there's no NAs left. So if I pull this back up, let's take a look at that. So once we've done, see there's a summary before and a summary after. See this? So this is the summary, test data 3, identify any NAs. In the numeric columns, we have one here for horsepower, and we have one here for miles per gallon. So we need to remove those. NAs are obviously where we just don't have the data, missing values, I guess they would say. And so next, if you see after I've done that and after I replace them, so this is the code right here to replace them. Replace, lapply, and na.aggregate right there. So once I run this line of code, and if I run the summary again, we can see here that horsepower and miles per gallon no longer have the NAs. They're gone. So that's our test to make sure we remove them. Then we determine the correlations, right? So what we're going to use is the core function. And what I'm showing you here first is the original data set had NAs in it. So core does not work on those. When you run core test data 3 miles per gallon and cylinders, you run that, you get what? NA. It tells you there's NAs in it. So once you've removed them, so remember when we removed it, we put it into test data 4. So test data 3 has the NAs, test data 4 does not. So when you do this, you end up with an actual correlation score. Now keep in mind, what is it? If you have closer to -1 is a strong negative correlation, closer to +1 is a strong positive correlation. The closer to 0, the less significant or insignificant your correlations are. So we have, and anything above 0.5 or below 0.5 is considered a strong correlation. Okay, so in this case we have a -0.76 for miles per gallon in cylinders. That's a strong correlation. We also have mile per gallon and weight, and that's a -0.82. And these make sense. So obviously as your cylinder numbers go up, your miles per gallon go down. As your weight goes up, your miles per gallon goes down. Okay, that just makes common sense. We also have, if we do miles per gallon in model year, we have a positive correlation of 0.56, 0.57. Okay, and what that means is a strong positive correlation. So as model year gets newer, miles per gallon tends to go up. That makes sense too, because things get more efficient. They put more efficiencies in these vehicles. They find ways to make them run leaner, stuff like that. So we also can do a miles per gallon versus origin, right? So that's what we did here. And we end up with a 0.56. So the same thing, almost the same correlation there. So based on where it's manufactured. So some countries, you'll know this makes sense because some countries have higher inspection standards and higher requirements of automotive manufacturers than others. So that makes sense there. If it's manufactured in a less specific country, or a country that doesn't have these fuel requirements or emissions requirements, well, then they may not make it as efficient on purpose. They might just be looking for profits and stuff. So then we also look at model year and origin. I want to show you that not all correlations are strong. So in this case, if you look at the model year instead of miles per gallon versus origin, it is a very small and insignificant correlation. So I'm not going to use that in this case. 0.19, 0.187. So now we could also, if we had all of our columns were numeric, we could use the core versus against the full test, the full data set. I can't use that here. It would give me an NA or an error, and the reason being is we have character columns. Okay, there are some character columns like manufacturer and stuff like that. So next what we're going to do is we're going to build the linear regression model. So it doesn't matter if you look at it here, if you look at it here, it's the same thing. Let's go down to building the same thing, part 5. The code is the same. Remember, the code is always between these R brackets, okay? And the rest is not, is in between them, okay? So sometimes if I have errors, or not errors, warnings and stuff, I will use these. The R, message, or warning equals false and message equals false to remove them, okay? And a warning does not mean it's necessarily bad. There's a lot of code that you'll run in R that'll give you little warnings, you know, that are many times meaningless, and you just want to remove them from your documentation in rMarkdown. So next, we're building the code, or building the models. So to build the models is very simple. It's an LM function, and you just do this. You know, you bring your test data with the NAs removed, and then you look at what two columns you're comparing. So in this case, I'm comparing miles per gallon, and model year. And in the second one, I'm comparing miles per gallon in cylinders. So we know that one has a negative correlation, this one, and one is a positive correlation. I wanted to use two of them. So we're making linear regression model 1 and linear regression model 2. Okay, if you look at the rMarkdown for this, we're right here. It's the same thing. When you run it, the print command, what it does, it actually prints the specifics behind it. You can see the intercepts of those. Okay. Next, what I do is, as a test, I want to get the R-squared values. How good of a fit are these models, right? So the R-squared value, the stronger it is, the closer to 1, the higher it is, the better the fit and explanation of the plotted points of the data. So when you look at that, we've got right here, when you hit print of that and you put summary of the linear regression model. So print does this, gives you the coefficient. Summary gives you the actual R squared values. So what you really want to look at is your adjusted R squared value, which is right here. And you have one that's basically 0.32 and one that's basically 0.58. So the 0.58 one is stronger. That is the miles per gallon of cylinders, the negative correlation. It's going to have a steeper curve to it, more of a downward curve, but it's a steeper curve. The other one will have an upward curve. We'll get to that in a minute. So next we tested again with ANOVA. So ANOVA, what it's going to do, it's going to give you the analysis, the variance, and the strength. And what you do is you look right here. So we've got the ANOVA of it. And what we want is the residuals of the mean square. So that would be, take mean square, residuals, and right there is 40.8 for this one and 25.1. The lower one is the stronger one. That's what you want. So what that's telling you is it's just backing up what we saw earlier. The adjusted R square value is higher here, and the ANOVA is lower for the second model. So it is more accurate. Next, what you want to do is you want to plot the original data and the trend lines, right? So I have some links in here in the code that I put here to other YouTube videos I have that show you lots of ggplot functions and how to use ggplot. So that's not what this video is about. If you want to learn more about that, please go watch those videos. But right here, what we're showing you is we're just going to use ggplot and a simple one. And we're just using our data set with the NA values removed, model year versus miles per gallon, geom point, and geom smooth. So what that does, it gives you a directional line of our data of miles per gallon and model year. So each model year, right, you have model years 1970 to 1982.5. It'll show you the breakdown, and that miles per gallon goes up over that time frame. Now remember, the second one, so that's a positive correlation. The second one's going to be steeper. Remember, it's a stronger correlation than the first one. So it's a steeper line, but it's a negative correlation because we're showing miles per gallon in cylinders. Remember, as cylinders goes up, right, the miles per gallon goes down. So if you have you have some cars that have a 3-cylinder, 4-cylinder, 5-cylinder, a few 6 and 8, right? As the cylinders goes up, the miles per gallon goes down. We saw it earlier. Next, what we're going to do is we're going to get the predicted values and append back to the original data sets. You already know how to make these things bold. I don't have to go through that, and I'm just making explanations here that I put in the rMarkdown page to better explain things. And I have two different pieces of code right here, right? One of them is commented out because I don't want to use them both, but I'm showing you the codes that you could do that if you wanted to. So I have it set up for both predict linear regression model 1 and 2. I'm using 2 because it's the stronger one, but I could also use 1 also. And what this does is basically we're getting the prediction values of it by using the predict function on it. See that? Predict linear regression model 2, interval equals prediction. You put that into this predict linear regression model 2, and then you bring that in with cbind and you bind that back to the original data set that has the NAs in it, and that's going to be called test data 5. So I always add the data to a new data frame every time I do it, or data set, and the reason being is I'm changing it, so if something gets messed up or wrong, I don't want to have to reload back in and go back to step 1. I want to be right here, so if I mess up here, I'm only messing up test data 5. I'm not messing up test data 4 or the previous original data set. I don't have to bring anything back in. I don't have to go all the way back to the beginning. So once you've done that, this cbind appends back the new forecasted values for the prediction values. Now let's graph a linear regression and get the prediction intervals in it. So whether you look at it here or here, it doesn't matter. I showed you how to put the code in here with the R blocks you can see behind here. But basically what you're doing here is you're going to use a ggplot function like we did earlier, right? With a little bit of difference. We're using geom point and stat smooth instead of geom smooth, and the method is linear LM and linear model, and then cylinders versus miles per gallon is the one that I'm using. See how this is flipped? So earlier you saw it miles per gallon, comma cylinders. I want to show the true what's going on with this. Remember, this is a negative correlation. And then you're putting this into plot 1, and then to add the prediction intervals, instead of just plotting this right here, what we're going to do is going to say plot 1 plus. So we're taking all of this, plus we're adding another set of lines, geom line, and color is black, line type is dashed. You can make it whatever you want, and then we have y is the upper, color is black, and line type is dashed. What that does, it gives us the upper and lower bounds of a 95% confidence interval. So we know that pretty much that's why this is a very strong negative correlation. You can see some of the dots are outside there, but the vast majority of them are inside of the bounds here of the confidence intervals. So what we just did is I showed you how to quickly make something in rMarkdown, and if you want to show it like this, let me close this out so you'll see how we do it. You just go here, you hit knit to HTML just like this. When you're done, it'll either error out if you had an issue, if you had some NAs in here, that'll quickly tell you that, but it doesn't. So here it is, and it usually takes you to the point that you were working on in it. But let's go back to the beginning. So here's the same exact rMarkdown that I was showing you. It's very quick and easy to make, very professional looking, has all of your code, your libraries. It has the code itself, the sample data. It shows the data very easy to read. You can see all the columns, all of the rows. You can see all the data throughout this, all of the results. You can see all of the test values, the graphs, everything all the way through. Very nicely documented. This is the way when you want to turn over a project to another team, to another team member, and you're saying, okay, I'm giving you this, you finish it, or this is now it's your part, or I've created this process and I'm being moved on or promoted to here. This is going to be yours now. This is a complete walkthrough, so this person would easily be able to say, oh, okay, I just do X, Y, and Z, and just follow along it. Great documentation is one of the most important things in data science and data analysis. There's an awful lot of people that do not know how to document, don't document stuff, and the problem is you got to live by the hit by the bus theory. So if you create a process, especially an arduous coded process, you want it so that somebody else can pick it up and run with it. If you don't create data or a process like that, you're creating loopholes and silos, and the problem is you're going to hold your company and yourself back. So instead, create stuff that other people can use, that they can quickly go in and follow it and say, okay, this is what I have to do, X, Y, Z, blah, 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 blah. Okay? Thanks again for watching. I hope you found this helpful and interesting. Remember, use rMarkdown. It's a great tool for documenting the processes that you create, whether they're more arduous. This is a pretty simple process, but it could be anything. You could create custom ARIMA models. You could create all kinds of stuff with this. But I'm just showing you here how to do it, how to show your graphs, and how to quickly make some awesome documentation. And then on top of it, this shows you linear regression from the beginning to the end. I will also post this code on researchgate.net, and I'll post the link down below. Thanks again for watching. Please take a moment to subscribe, like, and share, and have a great day. Thanks.